All right, geometry students, here we are for section 13.5. 13.5 probability models. A frequency table shows how often an item appears in a category. So we call that a frequency table. A probability distribution table shows the probability of each possible outcome and can be shown in a frequency table or graph. Give an example of mutually exclusive events and how to find their probabilities. Two events that can't happen at the same time, right? So two events that can't happen at the same time. All right. For example, all right. Well, how we find that, right, would be the probability of A or B. All right. And remember, that's equal to the probability of A plus the probability of B. All right. So an example of that would be what? All right. How about roll an even number? All right. And roll an odd number on one number cube or one die. Can't happen. All right. Circle the formula for theoretical probability. So theoretical probability is what should happen. Right? If I flipped a coin 100 times, I should get 50 tails and 50 heads. Okay, because there's a 50% chance of rolling that, all right, or flipping that. So the theoretical probability is the number of favorable outcomes over the possible outcomes. Now, if you flip a coin 100 times, you guarantee to get 50-50? No, that's the experimental probability if you actually sat down and did that experiment 100 times. All right, two-way frequency table, conditional probability and probability distributions related words. A two-way frequency table or contingency table displays the frequencies of data in two different categories. A two-way frequency table or contingency table can be used to find probabilities. Complete each statement with the word from the list. Use each word only once. Before they battled the blaze, the firefighters prepared for every contingency. Which blank has the greatest population density? Which continent? It comes from the same root word. Our rock climbing plans are contingent on weather. Okay. All right. A two-way frequency table or contingency table displays the frequencies of data in two different categories. You can use two-way frequency tables to organize data and identify sample spaces to approximate probabilities. All right, using a two-way frequency table, let's take a look. The table shows data about student involvement in extracurricular activities at the local high school. What is the probability that a randomly chosen student is a female who is not involved in extracurricular activities? Okay, so if you look at the activities, we have our males, right? We have our males right here. Okay, and then we have our females, and then we have our totals. Okay. And then what we have vertically is we have some other things. So we have involved in activities, not involved in activities, and we have our totals. So that's going to create our table, all right, for us. So that gives us what our sample space looks like. For example, there were 516 total students involved in this survey. Okay, to find the probability, calculate the relative frequency. So the relative frequency is going to be females not involved over the total number of students. All right, so my total number of students is going to be 516, and females that are not involved, that's going to be 120. All right, so I'm looking for that number over that number, right? Just by looking at that data. And that's going to come out to be about 23.3%, all right, for that probability. All right. That's all there is to it. All right. Is use that table to help find what you're looking for. Go ahead and pause the video and try problem number 1 here on your own. All right, the two-way frequency table shows the number of male and female students by grade level on the prom committee. What is the probability that the member of the prom committee is a male who is a junior? All right. Okay. So from the problem and the list of totals on the table, mark which of the following you need to find the answer to the question. All right. So which one am I going to need? Well, the first thing I'm going to need is I'm going to need the total of students on the committee. All right. I'm going to need the total students on the committee, and then from the problem on the table, which other group from the problem and the table, which other group will you need to know to answer the question? I'm going to need the number of junior males. Right. So circle which ratio to use to find the probability that the members of the prom committee is a male who is a junior. All right. So I have all my males here. There's 6 of them. Juniors, there's going to be 3. All right. So I have 12 total people on the committee. All right. And 3 male juniors. So I'm looking for 3 out of 12. So fill in the blank to complete the sentence there. The probability is going to be a prom committee is male who is a junior. That's going to be 3 out of 12, which is 25%. Okay. All right. The probability that an event will occur given that another event has already occurred is called conditional probability. You can write the conditional probability of event B given that event A has already occurred as probability of B given A is how we read that. All right. You read that as probability of B given A. So respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. What's the probability that a randomly selected person is over 60 years old, given that a person had no opinion on the state bill? Okay, so the fact that we were given that the person has no opinion on the state bill, we're looking to shrink the sample space. So if I shrink that sample space, I'm looking at the people who had no opinion, all right? And the total of people who had no opinion is 100. So the conditions that the person selected has no opinion on the minimum wage bill limits the total outcome now to 100 people. So instead of looking at the 1,000 people that we asked, we're now only limiting ourselves to the 100 that had no opinion. Of those 100, how many of them were over 60? All right. Well, if we look, that's going to be 40 total, right? So we have these 40 that were over total. All right. So that means that our probability out of 100, there were 40 total. So that's going to give us a 0.4 or 40% of the people who didn't care about the bill are going to be over 60 years old. Okay. So what we're doing is we are shrinking the sample space. All right. Okay. Go ahead and pause the video and try this one on your own. Respondents to the recent poll were asked whether they were for, against, or had no opinion about the state bill that would increase minimum wage. What is the probability that a randomly selected person is 30 to 45 years old, given that the person is in favor of? All right, so they're in favor of the bill. So now we are limiting ourselves here, right? People that are for the bill, right? Okay, so our sample space is no longer 1,000. Our sample space is now 780. Okay. All right. So let's answer some questions here. So the formula for the probability is P of the probability of the event. It's going to be the number of favorable outcomes or the total possible outcomes. Put a check in the box to the subset of people the question is asking about. So they are asking about those for the bill. How many possible total outcomes are there for people polled for the group you selected? As we already said, 780. So out of the possible outcomes, which age group is considered the favorable outcome? Our favorable outcome is from 30 to 35, right? So we're looking for 30 to 45, excuse me. All right, how many people are in that? 200. So use the formula to find the probability that randomly selected person is 30 to 45 years old, given that the person is in favor of the minimum wage. So it's going to be 200 out of 780. Pop that in our calculator and we get about 0.26 or about 26%. Okay. All right. So part B says, what's the probability that a randomly selected person is not 18 to 29, given that the person is in favor of the minimum wage? Okay. So if they're not 18 to 29, so now what I'm looking at is I'm looking at this whole subgroup here, and I'm not including that, right? So now if I do that, I'm going to have 200 plus the 120 plus the 150 out of the 780 total, right? So that's 470 out of 780, which gives me about 0.6, right, or 60%. Okay. All right. Good. Using relative frequencies, a company has 150 sales representatives. 2 months after the sales seminar, the company's vice president made a table of relative frequencies based on sales results. What is the probability that someone who attended the seminar had an increase in sales? Okay, so we're going to find frequencies first. So find the number of people who attended the seminar and had increased sales. All right, so what we need to do is we look at that attended the seminar and increased sales. That's going to be this 0.48. All right. We know that 150 people attended the seminar, right? Or excuse me, 150 employees. Okay. So if I do 0.48 times 150, that's going to give us that 72. So we're 72 employees who attended the seminar and increased their sales. Find the number of people who attended the seminar total, right? So if I look here on the frequency table, we have 0.8 or 80%. So that means 80%, all right, of the 150 attended the seminar. So that's going to be 120. So 120 employees went to the seminar out of the 150 total employees. So I want to find the probability that they increased sales given they went to the seminar. All right. So how many went to the seminar? 120. And how many increased sales? 72. 72 out of 120 is 0.6 or 60%. Okay. All right. Now, another method you can use is use relative frequencies. So the probability of increased sales, given their sales increase, is the relative frequency of the intended seminar increased sales over the relative frequency of the intended seminar. So that can be 0.8, all right, or 0.48 out of 0.8. So I don't necessarily have to calculate the actual number of people who did it like this. I can use the percents that were given to me in the table. So if I do 0.48 divided by 0.8, it's going to give me 0.6 or 60%. So that means that the probability that some who attended the seminar had an increase in sales was 60%. So the company could use this in saying that, there's the seminar had a 60% success rate. So should this company have another seminar? That's something that they can think about doing in the future. Okay. All right. Okay. Go ahead and pause the video and try this one on your own. A company has 150 sales reps. 2 months after the sales seminar, the company's vice president made the table based on sales results. What is the probability that a randomly selected sales representative who did not attend the seminar did not see an increase in sales? Okay. Which subset of sales represents the question that we're asking about? All right. So we are looking at people that did not attend the seminar. So we're looking for these people here, right? What is a possible outcome for the group you selected? Possible outcome of the group selected is going to be 0.2. So did not attend is this group right here. All right. Remember, 20% of the people did not go to the seminar. Out of the outcomes in number 18, which group is considered a favorable outcome? All right. That did not see an increase in sales. That's what we're looking for. So did not increase sales. All right. What is their frequency? So if we look for their frequency, we have 0.18. Okay, so now let's go ahead and do the probability of 0.18 over the probability of 0.2. So if we pop that into our calculator, we get 0.9 or 90%. So what is this saying? This says that 90% of the employees who did not go to the seminar did not improve their sales. All right, so if we combine the two problems that we just did here, all right, it was 60% effective for people who went. It was 90% of effective or not effective for people who did not go. So as the owner of this company, you can make a decision and say, I like those percents. Let's bring back this seminar the following year, all right, and require our people to go, all right, because this seminar helps increase sales. Okay. All right, go ahead and pause the video and do a lesson check on your own. Okay, the table below shows the results of a poll. A student was asked the question, if a Republican from this poll group is randomly selected, what's the probability that they do not support the issue? The student calculated the relative frequency as 33 over 33 plus 36, which is about 0.478. What error did the student make? All right, so let's take a look at, let's break this problem down. So circle the number of people in the possible outcome group. All right, what's the possible number here that Republican that of Republicans, right? So we're looking at these people here. So that's 60. Circle the number of people in the favorable outcome. The favorable outcome is that they did not support, right? So they did not support. So that's 33. Fill in the blanks to find the probability of being a Republican who does not support the issue. So that's going to be 33 out of 60, right? Which reduces to 11 out of 20, or 55%. All right, so explain what mistake the student made. They used the total number of people instead of the total number of Republicans. All right, so they used the entire sample set instead of just the Republicans. Okay, so if you see what they did again up here, that 33 plus 36, all right, is where they went wrong. Okay. All right. They got that. So that's where they got that 69 from instead of being the 60. Okay, great. Two-way frequency table. We've looked at many examples of those here. This is an example of one. We got two ways because we've got here in this case support or does not, and we've got Democrats and Republicans. So it's two different things that we are going to cross-reference. All right, and then conditional probability. Conditional probability is going to shrink the sample space. It's a simple way to think about it. I'm going to shrink the sample space. Like, for example, in the previous one, we shrunk it to just the Republicans. All right. In the other examples, we shrunk it to people who went to the business seminar. Okay. So that shrinks the sample space that compared to the total sample space for the whole survey. Okay. All right. So put a dot on the line of how well you understood today's material. You're now all set to do the homework for section 13.5. So go ahead and do that, and I will see you next time.